definitions. So chapter 10 is all about what's called solid geometry. So we're going to be looking at solid figures, shapes that are three-dimensional. So this is going to be kind of jumping into the three-dimensional land for us. And so if you turn, these are the notes that are posted in Google Classroom. So if you can print them up and do it with me, that's great. If you can't, just follow along the best you can. We do have the key to these provided on there as well. All right, and so when we're dealing with 3D figures, right, so we're just going to be working on classifying them and then using what are called nets and cross-sections to analyze 3D figures. We'll talk about what nets and cross-sections are here in a minute. To classify, there are some definitions we need to know. We need to know what's considered a face, and that's exactly what you think. It's just a flat surface on the 3D figure. If this is our 3D figure here, any one of those flat surfaces is considered a face, right? So any of those, so, if let me get some colors here. If I use my little purple here, like this top guy, for instance, the whole big flat thing, that is a face. Now they're all faces, but I'm just coloring in one for our use right now. An edge, again, exactly what you think of. An edge is the segment that is the intersection of two faces. So where two faces come together, if we look at like this guy right here, the bottom rectangle and this kind of front rectangle, they come together along this edge right here. Okay, so that's an edge, and there are lots of other edges, right? Anywhere two faces come together is an edge. A vertex is where there's an intersection of three or more faces. If you notice, when three of those faces come together, like for instance the top, maybe this kind of front rectangle, and then this like trapezoid here, where all three come together is a spot right there, a point, and that is called a vertex. Okay, so where three or more faces come together. So when two faces come together, they create an edge. When three faces come together, they create a vertex. Okay. All right, now there's different types of shapes we're going to be looking at. They're what are called prisms. A prism is a 3D figure formed by two parallel and congruent bases connected by faces that are parallelograms, and those are usually rectangles. And for the most part, that's what we're going to be focusing on, rectangles. So two parallel congruent bases connected by faces that are rectangles. So this guy, this is a prism. This is actually going to be called a trapezoidal prism. All right, if we look at let me get another color here. It says two parallel and congruent bases. Well, these two trapezoids, the one in kind of the back here and the one here in the front, these are our bases. They're congruent, they're identical trapezoids. Right? Those are congruent, identical trapezoids, and they are called the base of this. And this is where it's a little bit weird, right? We're used to saying base and bottom are the same thing. They're synonymous, and they're not. In our 3D world here, you cannot, kind of like we did when we were doing area formulas, the base is defined. It's something that's defined. It's not just whatever happens to be on the bottom, because you can take these shapes, these are representing real objects that you can spin them and move them and turn them. And so what is the bottom, right? I mean, the bottom is dependent on where it's oriented. And so we have to define base differently. The base for a prism are the two identical shapes. So the bases are these two guys. Okay, those are the bases. And this is called a trapezoidal prism because we got two trapezoids and it's a prism. And notice the two trapezoids are connected by all these rectangles, right? So that's what we're talking about here. So please note that the bases these are not on the bottom, but they're still considered our bases. Okay, we're going to see some cylinders. A cylinder is a 3D figure formed by two parallel circular bases. So you've got the two circle bases, right? Inside of that, you can't see them too well, they're super tiny, but there's a little h there for height. Oops, little h there for height. That's the height of the cylinder. And then There's also, this is just the radius of that circular base. So height and radius. And cylinder, and you guys have seen cylinder, right? You know those. You got lots of real world representations of cylinders, right? A tin can. You got what am I trying to say? Tennis ball can, something that we say often, right? You can any can. I mean, a cup, a mug, lots of things. Okay, and we see also this thing here. This is a pyramid. A pyramid is a 3D figure formed by a polygonal base and triangular faces that meet at a common vertex. So the base can be whatever, and then it's going to have all these triangles that come and meet at a common vertex. These triangular faces that meet at a common vertex. So it's got some polygonal base, right? So that base can be anything, right? But they're going to form, or they're going to come together and meet at this common vertex. So this is that common vertex we're talking about. All of the triangular faces here met together at that common vertex. And that base again is, so here's the common vertex. That base, in this case, is this rectangle. So there's your polygonal base. Okay. If you think about pyramids, I mean, you can literally think about the pyramids in Egypt. That's exactly what they are, and that's what we call that shape. The pyramids in Egypt are called square pyramids. Their bases, that base is a square for those. So they're square pyramids. Some of them may be more rectangular, and so you could call them rectangular period too. But I believe that the ones in Egypt are at Giza are square bases. We also have something called a cone. A cone is a little bit weird. It almost looks like a pyramid, right? But it's got a circular base, and so remember, a circle is not considered a polygon, right? Because polygons have edges that are straight, right? Straight lines, and so this is not, a cone is not a circle isn't a polygon, so this is not a pyramid. We call it a cone, and again, it looks like a flipped upside down ice cream cone, right? So that's exactly what you think of when you are talking about cones. And again, we do have for cone things that we need to know about. We need to know about the height, which goes from that point there. Again, we would call it a vertex. And it comes down to the center of that circle. That would be the height. And that center out to the edge, right, is called a radius. It's coming down at a right angle. Right, that's a right angle up there too. I probably should have put that in there. Right? And so you can see with the cone, there's almost a triangle being made here, which you can imagine what we might do with that in certain problems. Okay, then we have a cube, and you guys, again, you've seen cubes, you know what they are, right? A dice, anything that's got all 6 sides are squares, right? A 3D figure made up of 6 square faces. That is a cube. Nothing too much to talk about there. Okay, let's get into these are the last 2 pieces that are, again, for that second target. Talking about nets and cross sections. So a net is a diagram of the surfaces of a 3D figure that can be folded into the 3D figure. So this little picture here, if I were to, in essence, cut that out, fold on all those little creases, I should be able to fold it into the object. And so this one over here on the left, that is the net. So this is the net right here, and it should fold into that 3D object. Okay, if in one piece, if I were to cut it all out, just on the outside, cut it out on the outside in one piece, it should fold into that object. Okay, so that is what a net is. It's basically taking that 3D figure and like unfolding it and laying it flat with all of its faces showing. Okay, a cross section. Now this is one that can throw kids off, and I think it's from this desire to make it almost too complicated. A cross section is the intersection of a 3D figure and a plane. Now remember, a plane is this flat surface that can go on, infinitely, assuming. And if you put a plane through a 3D figure, the cross section is what is the shape that you see when you intersect them. So if you look, so here's the plane here, right? So this is this orange guy is the plane. Right, so there's the plane. And then of course you can see we've got it, this would be a pentagonal prism, right? We got two pentagon bases, prism connected by rectangles. So this pentagonal prism, this plane is sliding through it. And so the question is, what is the shape created by that? And it's that little piece right here that I'm gonna outline. That guy. That rectangle. That's the, or excuse me, not rectangle, that's a pentagon. And that pentagon is our cross section. One thing to note, if the plane is parallel to the base, the cross section will be the same as the base, right? So this plane is coming through this pentagonal prism parallel to the bases. The bases are the pentagons. So then what's the cross section? It's another pentagon, right? So I'm going to write that cross section as a pentagon. Remember, pentagon has 5 sides, right? Okay, so the cross section is a pentagon. So there's some definitional stuff. Let's look at some of the shapes. What are the shapes we'll see? And so can we classify? So this is called a trapezoidal prism, right? Because we've got, again, the trapezoid bases. So when you name them, the first piece is always the base. All right, so this is trapezoidal because we've got these trapezoid bases, right, in the front and back there. You can kind of see them, yeah. All right, those trapezoids back there, front and back. And then prism, because we're being connected by all these rectangles, right? So, and they are parallel and congruent rectangles. Or no, excuse me, not. The rectangles are not parallel and congruent. The bases are. The bases are parallel and congruent, and so that's what makes it a prism. And then how they're connected, they look like a bunch of rectangles, right? We got all these like rectangles going on here. Okay. An octagonal pyramid. So again, you name by the base. This has an octagon base, right? You can 1, 2, 3, 4, 5, 6, 7, 8. And then a pyramid because we got that common vertex, right? Pyramid because we got the triangles meet at a common vertex. That vertex is right there. Okay. So then it's just a matter of recognizing how these look. This is a hexagonal prism because our hexagons are the bases. All right, there's our base, the hexagons. All right. And a prism because they're connected, they're congruent and parallel, connected by these rectangles. This is a pentagonal prism. Now this isn't a normal, like what we call a regular pentagon, but it is a pentagon. It's got 1, 2, 3, 4, 5 sides. So we do have these. This one's a little bit funnier looking, but that's okay. We got these pentagons back here, right? And they're connected by, they're congruent and parallel, connected by rectangles. So it is got a pentagonal base, and the prism, we do have those parallel congruent bases. A triangular pyramid, right? The base is a triangle, and they come together to common vertex. Triangular prism, 2 triangles that are the bases that are congruent and parallel, connected by rectangles. Pentagonal pyramid, a pentagon base with triangles coming together to common vertex. Rectangular pyramid, or a rectangle base, triangular faces coming to a common vertex. So the names really, if you're just gonna, it's a matter of recognizing prism or pyramid and then naming the base. What is the base? All right, so following those definitions. All right, guys, I'm out of time. Bye.